In this video, we're going to talk about how to find the area between two curves. Now, in the previous video, we did the curve and the x-axis, and we're going to do that again just for a little further explanation. And then before that, I do want to say that in the note on definite integrals, you have to remember that if you have a definite integral that is using a function that has, say, 1 over x in it, and you know that when x is 0, the function would not be defined. So if your definite integral is going between -1 and 3, for instance, then you would not be able to evaluate it, because you can't find the area of something where the function is undefined. So just that little note for you to add to your knowledge base. So let's continue with this one today. So we're going to say let f and g be continuous functions such that f at x is greater than or equal to g at x. So what does that mean? If it's greater than or equal to, it means that the height of the function f at x is above the function g at x. Okay, so if you had two curves, something like this and this, f at x would have to be your upper curve, g at x is your lower curve, on the interval from a to b. Then the area of the region bounded between those two curves is going to be the integral from a to b of the upper function minus the lower function. So in some cases, you're going to have to determine which one is above the other one with respect to x. Always so respectful. So let's do an example. I've got, I think, 4 or 5 examples here for you. And maybe you might want to look or scroll through to see which ones maybe you don't understand, and write them down, do them, and then come back and check while I explain them. Find the area of the region bounded by the x-axis. Now remember, the x-axis is the line or the function f at x equals 0, or the line y equals 0, because on this line everything has a 0, right? 2, 0, 4, 0, a point. The graph of y equals minus x squared plus 4x minus 8, and the lines x equal -1 and x equals 4. Okay, so pretty easy to start. I know where x equals -1 and x equals 4 are, but I don't know where my ruler is, so I'll just have to sketch it. Oh, Miss Havrot. Okay, so I'm going to put in my boundaries here, and then I'm going to do a little bit worrying about, this is just to get a look of what it looks like, right? Don't have to worry about it being perfect. Although it's kind of nice to have perfect graphs. So I want to graph this parabola. It's a concave down parabola, as you remember from grade 10 onwards. A negative sign means concave down. And I need to know where the maximum value is. So if you recall, x equals minus b over 2a will give the equation of the axis of symmetry. The axis of symmetry, of course, has the maximum or minimum value on it. In this case, it will be a maximum value, again, because it's concave down. So minus b would be minus 4 over 2a, and a is 1 here, minus 1. And so that's going to give me x equals 2. So the maximum is going to be right here on this line. How high it goes? Well, we plug this value back in to this equation to find out the maximum height. So I have minus 2 squared plus 4 times 2 minus 8. So that's 8 minus 8. 2 squared is 4, and negative is minus 4. So 2 and minus 4, 1, 2, 3, 4. So I did a quick sketch here. It's going to be right here. Now, you don't have to be perfect at sketching it, but I do know that when x is 0, the y-intercept will be minus 8. And that means that this function will be the same distance to the line y equals 4, right? It's going to go, the line x equals 4, because if I'm 2 away from this minus 8, I'm 2 away from that minus 8, because remember that parabolas, make a little sketch here, this line has to be the same as this because it's symmetrical. So I'm going to have something that goes sort of like this and back down. So I extended this down because my boundary here was -1. So the area that I'm looking for, the area bounded by the x-axis, get out my wonderfully colored pencils, And that means I'm looking for all of this area here. Okay, just go to like that. Okay, so I know that my upper bound is going to be the line x equals or y equals 0, or the x-axis. So I'm going to write that over here, x-axis, y equals 0. So when I write out my integral now, I'm going to say, well, this is the integral between minus 1 and 4 of, well, it's going to be f at x minus g at x, because f at x is, this is my f at x. So I'm doing f at x minus g at x. So I'm doing 0, which is my f at x, and I'm going to subtract minus x squared plus 4x minus 8 dx. Okay, so I'm going to fix this up before I take the integral. So I'm going to go from minus 1 to 4. Minus and minus means I'm going to change all the signs in here. So it's going to be x squared minus 4x plus 8 dx. Put that in brackets between minus 1. Getting a little messy here. Okay, so now I'm going to integrate or take the antiderivative of this part of the equation. So I add 1, divide by 3, so that's 1/3 x cubed. Add 1 is 2, that's going to be minus 2x squared plus 8x, and I'm evaluating it between minus 1 and 4. Now remember, to take the definite integral, you're going to do 4, f at 4 minus f at minus 1. So now we're just going to plug those in. So I'm going to make a big bracket here, and I'm going to do 1/3 times, I'm plugging in 4 first, 4 cubed, minus 2 times 4 squared, plus 8 times 4. Now sometimes you might forget that you're not done yet. And then I'm going to subtract f at 1. So here we go. We're going to plug in 1/3 times 1 cubed minus 2 times 1 squared plus 8 times 1. Okay, so I guess I didn't need those round brackets there. So now you're just going to do the math part. Let's move this up for you. So it's going to be minus 1/3 times 4 cubed is 64. Minus 2 times 16 is 32, plus 32. Oh, that's nice. And then I'm going to subtract, and be careful when you're subtracting because you have to get the sign here before. So I'm going to have 1/3 minus 2 plus 8. And I'm not going to do all that and waste a lot of time for you, so I'm just going to tell you what the answer is, and you can try that on your own. So you get 31 2/3. Okay, so that's how you would do it. Now, I want to note right now that when we were doing the other lesson, we talked about the area. Remember, I would say if the function is above the x-axis, then your answer is going to be positive. If the function was under the x-axis, say between here and here, then this area would be negative. Now, when you're doing between two curves, and if I said why this was negative was because we should have been doing 0 minus this, which would make the area positive, right? And this one would have been this minus 0, so that's why this one was always positive. So think about that while you're doing these, especially where you have the x-axis. So you can see I got a positive answer, even though the area is below the x-axis, because I did 0 minus this. Okay, so just wanted to make that clear. Okay, example 2. Find the area of the region bounded by f at x equals 2x minus 1, g at x equals x squared minus 4, and the vertical lines 1 and 2. So now we're in between two curves. So the first thing I'm going to do is sketch it, and then in the second one we're going to find all of the area enclosed between the two curves. So x squared minus 4, that's an easy one to graph. It's just the parabola y equals x squared, shifted down 4 units. And And we're just going to, let's see if we, yeah, x squared minus 4. If I factor that, I would have x plus 2 times x minus 2. So that means my zeros are 2 and minus 2. So my graph's going to go like this. Remember with the last one, we couldn't find the zeros because it didn't have any, if you look back at that. Okay, and the other thing we're going to add in here, and now I really wish I could find my ruler, is the line y equals, oops, sorry, I'm going to make a big mess here. Y equals 2x minus 1. So 2x minus 1, that has a y-intercept of x equals minus 1. It has a slope of 2, so that means up 2 over 1. So that's enough for me to make my line. If I had a ruler, if I had $1 million too. Okay, so I'm going to use something that'll kind of work, like a piece of paper. These things work. So I'm going to draw my line like that. That's pretty good. And I'm looking for the first one. It says it's bound by the vertical lines 1 and 2. So if I put in the line 1 and 2, so here's the line x equals 1, here's the line x equals 2, and I'm only trying to find this region in here. So I'm going to just sketch it in. This is going to be here. So that's what I'm trying to find. So again, you have to figure out which one is above. So we've sketched it, we've identified the region. It's always below this line. So my line is f at x equals 2x minus 1. And my g at x was the parabola. And you can see in this case that the region is always underneath f at x. So it's below here. So that means that my integral, I'm looking for the integral between 1 and 2 of f at x minus g at x dx. So now I can just plug in the two values. So I'm going to go between 1 and 2, and I'm going to put in 2x minus 1 minus x squared minus 4 dx. Now, it's quite a smart idea to simplify what's in the brackets here. So I'm going to have negative x squared plus 2x, and this is minus a minus, so that's going to be plus 3 dx. And now it's much easier for me to take the integral. Okay, so minus x squared, add 1, divide by 3, so that's going to be minus 1/3 x cubed. Add 1, divide by 2, that's going to give me x squared plus 3x, and between 1 and 2. So remember, now you plug in 2, evaluate, subtract with 1. So 2 cubed is 8, that's going to be minus 8/3 plus 4 plus 6, subtract minus 1/3 plus 1 plus 3. And again, I'm not going to waste your time doing elementary math. You can do that on your own, and you should get 11/3. Now, the question could have been different. It could have said, find the area completely enclosed for the above. So we're going to do the same thing, but this time we're going to find all of this area, which I'll put in green. Now, the problem is that I wasn't given any boundaries, right? So I need to know what is this point and what is this point on the graph. So in other words, I'm looking for the point of intersection of this curve with this line. How do you find a point of intersection? Well, you set them equal to each other. Remember, you're doing that as well in previous grades. So the first thing I need to do is equate the two equations. In other words, just set them equal to each other and solve for x. So I have x squared minus 4 equals 2x minus 1. Bring it all to one side. So x squared minus 2x, bring this over, adds, minus 3 equals 0. And now I need to know what multiplies to minus 3 and adds to minus 2. And you should get minus 3 and 1. Right, so it gives me x plus 1 times x minus 3. If you're having trouble with factoring, you can go back to some of my previous lessons, maybe as far back as grade 10 might be a good review. So that means x equals minus 1 and x equals 3 are my boundaries. So my AB here that I'm looking for is going to be minus 1 to 3. So now I'm going to plug this in. I'm going to do the integral between minus 1 and 3. So this is going to be, where should I start it? I'll start it over here. Oh, looks like I'm going off the page again. Okay, so let's do this. The integral between minus 1 and 3 of f at x, so the one that's above is 2x minus 1. So I'm going to do 2x minus 1, subtract the other one, the one that's underneath it, my g at x, dx. Okay, that's a 4. X squared minus 4. Okay, so now we're going to simplify what's in the brackets first. Always start with that. Don't try to make your work any harder than it has to be. And we did this previously, right? So we have the same thing as we had in the question up above. So that's minus x squared plus 2x plus 3 dx. We've even taken the integral above, so that's going to save us a lot of time. So that's going to be minus 1/3 x cubed plus x squared plus 3x. And this is all going to be between minus 1 and 3. And there we go. We're just going to plug some numbers in here. I like equal signs. I know some books don't do that, but frankly, these are important. It's format. So minus 1/3 of 3 cubed plus 3 squared plus 3 times 3 minus, put a bracket. Always put a bracket there. Can you see? No, you can't. Need more space here. For some reason my setup today is a little off scale. Okay, so I'm going to put in a minus 1 now. So be really careful with negative numbers, as you know. Plus 3 times minus 1. Okay, so now you get to do some fun math. Do we want to do it? Not really. The answer comes out to 32 over 3, or 10 2/3. Okay, so that's two different ways with the same example with boundaries, and one where you have to find the points of intersection. And that's generally what you have to do. You often have to find those points of intersection before you can do the work. Okay, get that page out of the way. I have another one here for you. This is x cubed minus 4x squared plus 3x. Y equals 0. Okay, so we're dealing with the x-axis this time. A equals 0, B equals 2. So A equals 0 and B equals 2, those are going to be my boundaries. So I'm going to put them in here. That's going to be my 0. I make my scale 1, 2, 3. And B equals 2. Okay, so we're in here. Now I need to graph the function. So if you're trying to graph a cubic function, the first thing you want to do is look for, you want to factor it, right? It's a positive cubic function. So if I write this x cubed minus 4x squared, what would be the first thing you should always do when you're factoring? And I can hear you yelling it, look for a common factor. Absolutely. In this case, we have an x. So I have x squared minus 4x plus 3. And I need to factor this. So it multiplies to 3 and adds to negative 4. So minus 3 minus 1, right? X minus 3, x minus 1. So that gives me the zeros, or the x-intercepts are 0, 1, and 3. Now, obviously, the 3 isn't going to really matter here. So I have 0, 1, and 3. It's a cubic function. It has a positive leading coefficient. And if you recall, that means a positive leading coefficient is going to go from this quadrant to this one. So I'm going to start here. I'm going to go up, down. It doesn't matter how high I go up or how high I go down here. And I'm going to go like this, right? There's my cubic function sketch. Now I'm looking for the area bounded by 0 and 2. So this is my 2 here. This is 2 here, right in between. So I'm looking for this area plus this area. Okay, so I need to know which function is above and which function is below. And I think you can see that between here and here, f at x is above g at x, because g at x here, g at x equals 0. Y equals 0, that's my lower function. So in the first case, I'm doing f at x minus g at x. And from here to here, I'm going to be doing g at x minus f at x. So this one is above here, but this one is above in this from 0 to 1. Now that's why it's important to get your sketch on, because if you just said between 0 and 2, these areas would probably cancel each other out. And you're going to get some wacky answer, and you're going to wonder, what did I do wrong? So you need to be able to do a quick sketch so that you know where, well, we found the points of intersection, right? Basically, we didn't have to do any work because this was the line y equals 0. So all I needed to do was find the x-intercepts. So my first is going to be between 0 and 1. And I'm going to be doing f at x minus g at x. So g at x is 0. So that's just x cubed minus 4x squared plus 3x. And if you want, you can put minus 0 in here, just so that you remember this was your f at x, and you're subtracting your g at x dx. That's this first part. So we really have two little regions. So the second one is going to be between 1 and 2. And this time it's going to be 0 minus this one. And I'm going to write that in. It's important because if not, I might make a mistake with my, my signs, right? So minus this one, x cubed minus 4x squared plus 3x dx. I probably should have a big bracket around this because the dx applies to everything. Let's make it pretty. Okay, so now you're all set to do it. The rest of this is pretty simple, right? So because I'm subtracting 0 here, I don't have to worry about that. I'm just going to take the antiderivative of these three terms. So that's going to be 1/4 x to the 4th minus 4/3, that's my pencil again, x cubed. Add 1, that's going to be 3/2 x squared, evaluated between 0 and 1. And to that, I'm going to add, now remember, we're going to change the signs of this. So basically, it's going to be the same as this, but with different signs. So it's going to be, well, I'll leave the plus sign there just for now. So I add 1. So it's going to give me minus 1/4 x to the 4th plus 4/3 x cubed minus 3/2. Be really careful with those negative signs, right? And that I'm going to evaluate between 1 and 2. Okay, so again, the rest of this is tedious labor. This one's easy because you're subtracting the value at 0, which is just going to be 0. So let's just do this quickly. I'm going to have 1/4. I'm plugging in 1 here, so it's only 1/4. Plug in 1 here. 1/4 minus 4/3 plus 3/2, which means you're going to have to find a common denominator, right? And from that, I'm going to I'm going to subtract. Now I'm going to add it. I'm adding it in here. So I'm adding, and here we go, because I already applied the minus sign when I did the integral. Okay, so I'm going to do 2. That's 16. 2 to the power 4 is 16. 2 to the power 4. Yeah, 16 divided by 4 is going to be 4, and it's negative. So minus 4 plus 32 over 3. That's an easy one. And 9 times 3 is 27 over 2. 2 squared is 4. 12 divided, what am I doing? Minus 6. And then I better put a big bracket here, because it's this one minus f at 1. Be really careful, right? I almost made a mistake here. So this is going to be minus 1/4. Put in the 1, so I have minus 1/4 plus 4/3. 4/3 minus 3/2. Bang, bang. Okay, and again, I'm not going to do all this basic calculation. You're going to end up with 3 over 2, believe it or not. You're going to have to find a common denominator, and yeah. Obviously here we got 4, 3, and 2, so you'd be put them over 12. These ones, 12 for this. This one, you're going to probably end up in them all in 12ths. And I think it becomes 18 over 12 before you get down to 3/2. Okay, so that's, again, the number crunching is the part that's going to be a pain in the butt, right? Okay, and the last one I'm going to do for you is x to the 4th. X to the 3, sorry, x cubed minus 6x squared plus 9x, and g of x is x squared minus 3x. So I need to graph all this, right? Because I'm going to have to find their points of intersection. Where do they cross each other? Do they cross each other more than once? That sort of thing. So let's start by graphing this cubic function. Again, it's a positive leading coefficient. There's a 1 here, it's positive. So that means I'm going from this quadrant to this quadrant. So if I can find the zeros for that function, it's going to be pretty easy. Okay, so let's factor out an x. So I'm going to get x squared minus 6x plus 9. And that should look really nice to you, because this is a perfect square trinomial. So I have x what multiplies to 9 adds to negative 6. So it's minus 3 minus 3. So it's minus 3 squared, right? Squared twice the product squared. So that means I have a double root at 3, and I think you probably remember what that means. So the function's going to look like this. So I have a 0 here. I have another 0 at 3. This 0 is a double root. Remember that? So it comes down and just touches the x-axis and goes right back up. So I'm coming through here. Might be a nice idea to find something in between. So I'm at like 1.5. Oh, that's kind of nasty. But it's definitely going up. Let's say it was 2. That'd be 8. 8 minus 24 plus 18. So it's going to be up here. Let's just take a guess. And again, we're just looking for, it's going to come down, just touch it, and it's going to go right back up. Okay, so there's a quick sketch of this function. The other one, x squared minus 3x, again, I'm going to have to take out a common factor. That's really easy, because I know my x-intercepts are 0 and 3. 0 and 3. I'll do this one in green. 0 and 3. Let's see what happens when x is 4. If x was 4, I'd have 16 minus 12 is 4. So this one's going to go up to about here. And so it's going, what did we say, 0 and 3. So it's going to be going like this. This, and like this. And maybe this one's a little steeper. So right now, I'd say, okay, well, here's the area here. But I need to know where this part intersects. So my sketch is kind of not so good, right? So what I want to do is I want to find those points of intersection by setting these equations equal to each other. Let's start with that. So I have x cubed minus 6x squared plus 9x, and I'm going to set that equal to x squared minus 3x. Might have been a good idea to do this before sketching it, but it gives you an idea anyway. X cubed, I subtract 1, that's going to be minus 7x squared, and I'm going to add 3, that's going to give me 12x equals 0. Where are they equal? A common factor of x, that's always nice to pull out before you begin. 7x plus 12. What multiplies to 12 and adds to negative 7? Ooh, nice. 3 and 4, right? Minus. Oops. So excited. Got it so fast. So x minus 3 times x minus 4 equals 0. Okay, so now I've got all the points of intersection. When x is 0, when x is 3, and when x is 4. So obviously, I'm a little bit out here. This line should have crossed when x is 4, so it would have to come up more like that. Maybe a little steeper curve. Let's just put it here. I'm just going to get rid of this one. And that shows me that I have this little piece here and this big piece here. Now, what you want to look at here is which function is above. Remember, it was f at x greater than g at x. So in this case, my f at x is greater than g at x. So the first part of my integral, to find this area, is going to be between 0 and 3. And it's going to be f at x minus g at x dx. So that's between 0 and 3. And the second part is going to go between 3 and 4, our point of intersection. So I'm just going to make this here so you know what we're talking about. So this little green part in here, so this is area 2, this is area 1. Area 1 plus area 2. And that's going to go between 3 and 4. Now this time, look, the green line was above. The green line is g at x. So I'm going to do g at x minus f at x dx. Okay, so now you're all set to plug it in. You found out which curves are above each other, which one's below. So this is, again, the integral from 0 to 3 of x cubed minus 6x squared plus 9x minus x squared plus 3x dx, and the integral between 3, bounded by 3, and 4 of g at x, that's going to be x squared minus 3x minus, and I'm changing all the signs as I do this to do it in one step. Remember to change them all, dx. Now you want to simplify it, right? X cubed minus 6 minus 1 more, so I have x cubed minus 7x squared plus 12x dx. And this one is going to be between 3 and 4. I have 7x squared minus 3 minus 9. Oh, I forgot the cubed first. Should have put that one in first. Missed it. Okay, so I have minus x cubed. And what did I say? Plus 7x squared. X cubed plus 7x squared minus 12x dx. Okay, now we're all set. And what you need to do next is to take the antiderivative of each of these. Add 4, divide by 4. That's a quarter x to the 4th. You're probably seeing now that there's a lot of fractions in this work, right? Got to be pretty good with this. Minus 7/3 x cubed plus 6x squared between 0 and 3 plus, and this one we're going to add 1. That's going to be minus 1/4. I'm going to put a bracket because I've got plus and minus. I don't want to make a mistake. So I have 1/4 x to the 4th, add 1, 7/3 x cubed. I bet you're getting really good at doing these. Minus 6x squared between 3 and 4. Okay, so again, we're at the point where it's pretty easy for you to just plug the numbers in. Maybe not easy. It's tedious work, right? But it has to be done. You want me to do it? No, you don't. I'm just going to tell you what the answer is because this video is getting too long anyway, and my voice is starting to go. So you should get 71/6 for your answer, but I think I've made it clear how you're about to do it. The rest of it is just plugging it in, maybe even get out a calculator if you need it. Be careful here. This is going to be plus and minus, so this is just really minus this, minus that, right? We're all set to go. Okay, so I hope that helps you out and that you feel a little more comfortable doing areas between curves. Bye for now. Don't forget to subscribe, tell your friends. Not too many people subscribe. I don't know why. Don't you love me? Bye.